한국어를 해요 원래.
영어로 해요.
아 영어 부끄러운데요.
뭐 부끄러워 맨날 같이 하는데. Why?
Quantum theory for gravity, in other words, is quantum gravity. This is Earth in metrics. In space, general relativity and special relativity says that time and everything can be curved, and when something travels on the way through, everything is in metrics infinitely, and every time something goes, it's surrounded, but it's moving, so it's almost impossible. And this is the description of Earth in that point. This form we'll call it mu. This is mu, and this is in here, and we call this mu too. If we square this, then it becomes this, and if we squared this, so we're gonna square this too, and it's gonna be mu squared, and mu squared. So this is mu squared. This is mu squared, and so this is same as this, right? Here, and we just change this to mu squared. And so this is the description of Earth. In this form, we have this mu, we have mu right here, and this is exchanging between the value of the coordinate plane delta n and the delta of n. It's this exchanging between delta n and delta of n, but delta is on cap delta n, delta of n, and this gamma n and mu square, which is the thing which is obvious, and this is equal to this. I mean, this is equal to this if we use this form. So if we simplify it, it's phi, and we have the big, we can cap it, and if the value is 0. So this form is equal to this form. I mean this thing, and if we put this thing here, then it'll become this form. But these are nothing. These are no values, so it's nothing. But then if we see, this is all 0. This and this is 0, so it means that this is equal to this. And this is equal to 0. So this is equal to this, and this is equal to this. That means this is equal to this. And this part is where I hate very much, which is using probabilities. So I can't do the calculation because I don't know how to. And this is the simplest I can make. In this form, I can't make it more simple. This is the simplest I can make, but if I learn later on sigmas and more, then I'll probably simplify this into an even simpler form like this, because I needed no complicated concept of mathematics. So this was beautiful. And we have this too, but I can't simplify this yet, but I will.
Yeah.
And in wave particle duality, we have Louis de Broglie's this form, and this form is it's represented in Louis de Broglie as Louis de Broglie put it as mu2, and then he did this. Very amazing. Einstein first said that light is both made of particles and waves. People knew that light was already a wave and can be described as a wave, but there were cases like black body radiation where particle goes in and goes bouncing inside the thing, and in that black body radiation, scientists calculated, and the equation and formula of the wave was totally different from the experimental value of the particle. This made scientists wonder, and Einstein said, what if light is made of both particles and wave? And light was made of particles too, called photons. 광자. Yes. And Louis de Broglie thought of that and made wave-particle duality. Wave-particle duality. And then, with that form, he was pretty smart with it. I will draw something called a Bloch sphere. 뭐야?
싱크로트론.
뭐야?
광사광 가속기 연구소.
거기 가고 싶다.
네.
In Bloch sphere was in a symmetrical thing as fermion and bosons, which was used in Dirac's equation. So let me first draw a basic, most used example, which I wrote it down here also. It's in SP4. FX4. And okay, so this is the value. this is what I learned today in Think Root. This is symmetrism of fermions and bosons. And then, so it doesn't look like this. It's exactly the same right here or here or here, but most people use it here. And right here is the Bloch sphere. This is the Bloch sphere, and it has altitude going up, down, every direction, infinitely, like a space, universe. And so we will write this is universe, but most of the time we say U for the total thing. And then the Bloch sphere is everything gets stretched out inside the Bloch sphere of coordinate planes. In here, if we minus all of them, this comes out, phi. Phi is this thing. It's in Chipap. If we minus everything out, then phi comes out. Phi is Chipap, but there's nothing inside. But we won't take this out because we don't want, our goal is to not let phi come in. Our goal is to block phi because phi is attracted to Bloch sphere. So phi will become a particle and act as an electron because electron is same as light, can act as particles in wave. So phi coming, Bloch sphere should move away, but then it doesn't move. So what it does is it stretches so thin that phi could miss like this. When phi goes here, phi was trying to hit not into the center, it could just hit anywhere because the Bloch sphere is so big. But the Bloch sphere stretches like this, and then it stretches so the phi can't see because it has no volume. So phi can't see and phi just goes. And this is the way how Bloch sphere avoids phi. Bloch sphere avoids phi because phi is an electron. This is what is happening inside the conformal boundaries, which is the universe. Electrons are going past through a very small space inside the conformal boundaries, and then they're going in a really small space. But if we zoom in, it goes until infinity. That's very weird about conformal boundaries because there is a hole indeed, and if we zoom in, the hole is actually the same. So we can zoom in for infinite times, and the electrons are keep passing because electrons go smaller than infinity, minus infinity. Very weird. So we get V, and P, and then we get mu, which is changing the value of electrons and photons. And if we put in n1 over n2, then we have the same equation with that, except that there is a delta n in front. The